Okay, let's take a look at some dimensional analysis problems. This tutorial will cover A and B, and we'll move a little more slowly than the next one that covers C and D. So ironically, dimensional analysis is one of the first topics we cover, but probably one of the most useful as you go on and study physics and other advanced sciences. So it's really going to behoove you to master this technique, and it's also something, frankly, that we use every day in chemistry class. Dimensional analysis is really just a fancy word for thinking about units, doing unit conversion, and thinking about how the units cancel in equations. We're going to be focusing for the first part of dimensional analysis on how we convert from one unit to the next. So let's think about our strategy. We're always going to start with the given unit and start with what we're given and convert that and think about our pathway to the final unit. In this case, we're going from 42 feet to yards. And we're really going to sort of walk out the problem or sort of stretch it out by thinking about how the units cancel with one another. So I like to think about units being algebraic parameters, and I'll show you what I mean by that in a second. We're then going to use the appropriate conversion factors and put in the numbers that relate between the different units. And finally, we're going to check significant figures. And I know some of you might not have covered it yet, and that's okay. You can come back to this part if you want review, or just simply ignore it for now. I also want to think about whether or not my final answer should make sense. So that might be a step 4 prime or 5, if you will. Notice that we start here with 42 feet. How many yards should that be? Well, we know that from experience that a yard is larger than a foot, so therefore we should expect an answer that is smaller than 42, and that's always a good check, especially as we move into more chemical examples in the future. All right, so let's start this problem. We're going to start with feet, and we know ultimately we have to go to yards. Now, many of you could probably do this, with a calculator using a simple calculation, but obviously here we want practice with dimensional analysis. Now, I like to think about units as being sort of like an algebraic parameter that we have already looked at in our algebra classes. And what I mean by that is, suppose we have A and we want to go to B. Well, we could imagine putting A in the denominator here and canceling it out and multiplying in the numerator by B. What this will leave us with is a situation where the A's cancel and we get B. And that's basically how I'm going to think about dimensional analysis problems. So let me show you what I mean by that. Here we have 42 feet. Now, I might not know initially how to go to yards, but the very first thing that I'm going to do is put feet in the denominator. And by putting feet in the denominator, I know that they're going to cancel. Now, fortunately, we know that there is, in fact, a numerical relationship between yards and feet, and that's something that you probably have already memorized growing up. But in particular, we know that there are 3 feet for every 1 yard. So we can add that in as follows to the expression. Multiplying it out, or dividing by 3, if you will, you get 14 yards. So 42 feet is 14 yards. So get used to the framework about thinking about units canceling and putting units in the denominator to cancel with the previous unit. And that's really a benchmark of any dimensional analysis calculation or problem. Finally, I'm going to check my significant figures. Again, if you haven't gotten there, that's okay. But we know for multiplication and division that we're going to keep the fewest number of significant figures. Now, 42 feet has 2 significant figures. That's pretty straightforward. Remember that many conversion factors are exact definitions. So in other words, there are exactly 3 feet for every 1 yard. That's not a measurement, and it doesn't have any significant figures. So therefore, we're going to argue that they have an infinite number. We're not going to worry about them in the problem. So therefore, our answer, which came out of the calculator as 14, is in fact right. Do not be fooled. Many answers that do come out of the calculator are incorrect. All right, let's move on to letter B. Here we want to convert between miles and centimeters. Again, let's think about whether or not our answer should be smaller or larger than 0.067. Obviously, there are many more centimeters in a mile than vice versa, so the answer should be larger than 0.067. So thinking about this problem, we know ultimately we want to go between miles and centimeters. I don't think any of us have a good way to convert between directly miles and centimeters. In other words, we could imagine creating a conversion factor where we went between miles and centimeters and the miles would cancel. However, I don't know a good way to actually calculate that. In other words, I don't know what the numerical relationship between miles and centimeters is. This is where dimensional analysis is really, really powerful, and this is where it's going to help us out a lot this year. What I'm going to do is simplify this question and imagine that if I could go between miles and kilometers, and I think we do know a way to do that, I could get closer to centimeters. I could get closer because I know I can get to meters from kilometers. And from meters, I know I should be able to access centimeters readily. So we're going to imagine creating a string of calculations. So let's set up the units. You can add the numbers now if you want, but setting up the units is at the very least what you should do. As we think about these conversion factors, we know the first one, miles, has to go in the denominator because we want to cancel out miles. And we know how to go between miles and kilometers, and that's why kilometers is in the numerator. And the next conversion factor, kilometers, should be in the denominator to cancel out, and in the final one, meters should be in the denominator as well. You'll always be given the conversion factor between miles and kilometers. That's not one that you need to memorize. However, you do need to know the last two, that there are 1,000 meters in 1 kilometer and there are 100 centimeters in 1 meter. Multiplying this out, we get a larger answer as expected. Let's take a look at significant figures. Note that our starting value had 2 significant figures. The leading zeros are insignificant. So our final answer should have 2 because there are an infinite number of significant figures in the conversion factors. So if we need 2 significant figures, it makes sense to use scientific notation. And that's what we've done here. We have 1.1 times 10 to the 4th centimeters as our final answer.